welcome back. We'll be looking at the next set of exercises. So looking at sub-question C, we have that we have to look for the integral of x squared over the square root of x squared plus 7, right? So if we look at our rules, we'll see that for this particular case, we can use the substitution of x being equal to a tan theta. And obviously, since we have x squared plus 7, we know that 7 is just the square root of 7 squared. So our a is just root 7. So we have root 7 multiplied by tan theta, right? So then, now that we have that, therefore that means that our dx will be equal to root 7 multiplied by sec squared theta, right? And therefore our x squared plus 7 will just be root 7 multiplied by tan theta all squared plus 7, which is equal to 7 multiplied by tan squared theta plus 7, and 7 is a common factor, so we can take it out. We have 7 multiplied into tan squared plus 1, right? And that is just equivalent to 7 multiplied by sec squared, right? Taking it back to the original integral, we have therefore x squared is just equal to root 7 multiplied by tan theta all squared, and our dx, we found that it was root 7 multiplied by sec squared d theta, and the square root of x squared plus 7 will just be the square root of 7 sec squared theta, right? So we can clearly see that we can simplify root 7 in the numerator and the denominator, as well as sec theta. Then we left with the integral of 7 tan squared theta sec theta d theta. We know that tan squared theta is just equal to sec squared minus 1. So we substitute that, and we get the integral of 7 multiplied by sec cubed theta minus sec theta d theta, which we can break up into two integrals. The integral of 7 sec cubed theta d theta minus the integral of 7 multiplied by sec theta d theta. Now, to find the first integral here, we can use the reduction formulas that we mentioned earlier, and if we solve for the entire integral, we can find that the final answer will be 7 multiplied by half sec theta d tan theta plus half ln of the absolute value of sec theta plus tan theta, all minus 7 multiplied by ln of the absolute value of sec theta plus tan theta, all plus c, the constant of integration. So now that we have that, we are done with that question. So moving on to the next question, we have the integral of cos theta d theta over the square root of 2 minus sine squared theta. Right, so for this case, we can see that it doesn't really look like any of the four rules that we are looking at. So we'll try to manipulate the expression to have that. So first we do an initial trigonometric substitution. So let's say we let our sign here be equal to x. Therefore our dx will be cos theta d theta, and d theta will just be dx over cos of theta. Taking it back to the original expression, then we have that it's equivalent to the integral of dx over the square root of 2 minus x squared. down. Now this is a form that is equivalent to one of the rules that we are looking at, and in that case we can use the substitution x is equal to a sine u. In this case we used u instead of theta, just so we don't confuse with the original theta that we had before. So u is just some arbitrary angle that we are using for our substitution. So in that case, what is our a? Well, we have that the square root of 2 minus s squared is just basically equal to the square root of 2. Sorry, it's equal to the square root of 2 squared minus x squared. And in that case, a is equal to 2. Sorry, rather the square root of 2. So our x is equal to square root of 2 multiplied by sine of u. And therefore our dx will just be the derivative of that, which is the square root of 2 multiplied by cos u du. And from the original substitution, we can see that that means that our u therefore will be sine inverse of x over the square root of 2. And now that we know that, we can use it in the substitution of what's in the denominator. In the denominator we have 2 minus x squared, which will just be equal to 2 minus root 2 sine u all squared, which is equal to 2 multiplied by 1 minus sine squared u. And we know that 1 minus sine squared u is just equivalent to cos squared. So we have 2 multiplied by cos squared u. Taking it back to the integral, we have that therefore we have the integral of root 2 cos u du divided by the square root of 2 cos squared u, right? And that is equal to, we can see that we can cancel the square root of 2, we can cancel cos u as well, and we left with 1. So we have the integral of 1 du, which is just equal to u plus c. And we remember what is our u. Our u is sine inverse of x over root 2 plus c. And our x was sine of theta, if we remember correctly. So the final answer will be sine inverse of sine theta over the square root of u plus c, the constant of integration. Hopefully this makes sense. So moving on to the next example that we have the integral of 1 over x squared minus 2x plus 10. So in this case now we have a polynomial in the denominator, right? So it's a different type of exercise, and what we'll do here, we'll try to complete the square. So to complete the square, we know that x squared minus 2x plus 10 is just equal to x squared minus 2x plus 1 plus 9, right? And x squared minus 2x plus 1 is just equal to x minus 1 squared, and 9 is just equal to 3 squared. So this is what we have. And now in this case we can use u substitution, we can find that if we let u be equal to x minus 1, we have du is equal to dx, and when we do have that, then we can take it back to the original integral, and then we have the integral of du over u squared plus 3 squared, which is equal to 1/3 of tan inverse of u over 3 plus c. Because if you remember correctly, when we had when looking for the derivatives of inverse functions, especially tan inverse, we found that that is just equal to the derivative of the function divided by 1 plus the square of the function. And you can clearly see similarities with the original expression of under the integral sign here. Right, so that is where the tan inverse comes from. Now moving on to the last example. Here we have the integral of the square root of 4x minus x squared. Now we know that this is just equivalent to, rather, give me a minute, this is equivalent to the integral of the square root of negative x squared minus 4x, which if we complete the square will just give us the integral of the square root of negative, opening the brackets, x squared minus 4x plus 4, close the bracket, plus 4, right, dx. And we know that x squared minus 4x plus 4 is just x minus 2 squared. So we have that is equal to the integral of the square root of negative x minus 2 squared plus 4, which can be rewritten as the integral of the square root of 4 minus x minus 2 squared dx, which if we look at our original rules, we'll clearly see that is equivalent to us using the substitution x is equal to a sine theta. But in our case we don't only have x, we have x minus 2, so we'll use the substitution x minus 2 is equal to a, which is just 2 sine theta, and that means that dx is equal to 2 cos theta d theta, meaning that sine theta is equal to x minus 2 over 2, and that therefore means that theta is equal to sine inverse of x minus 2 over 2. Right, so we have that. We can take it to the problem, and we'll find that this is equivalent to the integral of the square root of 4 minus 2 sine theta all squared dx, which is just equal to the integral of, we know that 4 is a common factor, so we can even take it under the square root sign, and we have 2 multiplied by the square root of 1 minus sine squared theta d theta, which is just equivalent to, oh sorry, completely forgot something here. This dx is supposed to be 2 cos theta d theta, right? So we have 2 cos theta d theta here, and this is just equal to 2, the integral of 2 multiplied by the square root of 1 minus sine squared is just equal to the square root of cos squared, which is just equal to cos. So I have 2 cos multiplied by 2 cos d theta, and that just gives us 4 multiplied by the integral of cos squared theta d theta, which is equivalent to 4 multiplied by the integral of half multiplied into 1 plus cos 2 theta d theta. And this is an easy integral that we can find, and this would give us 4 multiplied by half theta plus plus 1/4 sine 2 theta, which I think that is, yes, if I'm not mistaken, that is that, yeah. And of course plus our constant of integration c. If we multiply in the 4, we'll have 2 theta plus sine 2 theta plus c, which is just equal to 2 multiplied by, if you remember, our theta is just sine inverse, so sine inverse of x minus 2 over 2 plus sine of x minus 2, sorry, made a mistake here, should be sine of 2 multiplied by sine inverse of x minus 2 over 2 plus c, which can be simplified further, and I'll leave that to you guys. Right. And yeah, so that concludes the final example that we'll be dealing with here, and I'll see you guys in the next video. Thank you for watching, and if you enjoyed it, just give it a thumbs up. Thank you. Bye.